Okay, we have another equation, and we're going to look for another variable. This time I happen to have variables in two positions, and those are the ones I'm looking for, and I have three variables in total. Just like always, I'm trying to get all the variables to the same side of the equation. So, and if I can isolate it, that's great. The first thing I'm going to do is I'm actually going to subtract xz from both sides. Just like before, even though it's got that other variable on it, just treat it like it's 2. If I wanted to subtract 2x from both sides, I'd just subtract 2x from both sides. And keep track of it very specifically. 3x minus xz, and then we got minus 2y equals 5. Now I'm going to try to get rid of the y. So, well, not get rid of it, but move it to the other side. So I add 2y to both sides. And I have 3x minus xz equals 2y plus 5. Now, the left-hand side of the equation has something interesting going on. With the left-hand side of the equation here, there's two different terms. Both of them have an x in it with a power of 1, which is important, because they're like terms. The problem is one of the coefficients is a number, the other is a variable. Here's the way it works. Let's look at a number example. If I had x times 3 plus 5, and I were to use a distributive property, I would just multiply x times 3 and 5 times x, right? That's what I would do. Just multiply each of the parts by it. Well, anytime you're given something where it has one variable in multiple terms like this, you can also do the reverse of distribution. So if someone had just ignored that even happened, someone gave me 3x plus 5, I could say, there's an x in both of the terms. Let's factor that x out. And I would be left with 3 plus 5. And then I would simplify things together, get 8. Oh, and hey, look at that. Isn't that just 8x? That's just what we do when we simplify terms. So what's happening in this problem is because both of those terms have an x in it, I can factor the x out. And I'm left with x times 3 minus z equals 2y plus 5. Now, just like we've been saying in all these literal problems, if it's not the variable we're looking for, we treat it like a number. Treat 3 minus z like it's the number 8, just like we had over here in my little example stuff on the right. What if you had 8x equals 2y plus 5? You would just divide both sides by 8. This time, we don't have 8. We have 3 minus z. So I'm going to divide both sides by 3 minus z. And I'll write it up here. Maybe move this stuff kind of out of my way. There we go. And the left-hand side, everything cancels out. And we're left with x equals 2y plus 5 over 3 minus z. And now I have the x term isolated all by itself on the left-hand side of the equation. And I'm done.